In this next problem, you're asked to calculate the molality of a solution of sodium bromide. And what you're given is you have 10.3 grams of sodium bromide dissolved in 300 mils of water. We know to solve this, you have to take your moles of sodium bromide and divide it by the kilograms of water. We know our moles of sodium bromide from the previous problem, and that was 0.100 moles. And what we need to get is the kilograms of water. But how can we get kilograms given that we have volume of water in milliliters? We have to assume the density of the water is 1 gram per mil. Okay, so we have our numerator, which is 0.100 moles. Now we need to get our kilograms of water. So we start off with the volume that's given in the problem. And we're going to use the density to get our grams of our water. So 1 mil of water is to 1 gram of water. And then what we can do is convert the grams to kilograms. So we have 1,000 grams of water per 1 kilogram of water. And this ends up giving us 0.300 kilograms of H2O. So the molality ends up being 0.333 molal. These next sets of problems, there's 5 of them, gives you practice with the problem types that have been assigned in your workbook as specific problems to look at for quizzes as an exam. So the problems listed here refer to your workbook in chapter 13 for problems types 1 through 3. We'll go ahead and go through the rest of these problems so you have the solutions accessible to you. Okay, so in this problem, we want to get the molarity of the solution. The information that's given in this problem is we have an 88% mass per mass of a methanol solution. Methanol, which I'm going to represent, is by MEOH. That's methanol. That's another way that professors often represent methanol. And we're given the density of the solution. To get molarity of methanol, I need the moles of methanol over the liters of methanol solution. Okay, and what I'm given is 88% by mass of methanol solution. So if I reinterpret this, this is 88 grams of methanol per 100 grams of methanol solution. So if we look at this, I have the information that I need from this mass per mass to be able to convert to moles and to be able to convert to grams. I can convert the 88 grams of methanol to moles using molar mass of methanol. The molar mass of methanol is 32.04 grams. So the moles of methanol ends up being 2.75. I have 100 grams of methanol solution. I can use the density to get to, in order to be able to get to milliliters, and the milliliters to be able to get to liters. So I'm going to take these 100 grams of methanol solution and And now I have 0.8274 grams of methanol solution per 1 ml. And I know that in 1,000 milliliters, there's 1 liter of solution. So this ends up being 0.1209 liters of methanol solution. My molarity ends up being 2.75 moles over 0.1209 liters. The molarity is 22.8 molar. In the second question, I have an aqueous solution of acetic acid. We're given the molality and the density. We want to find the molarity. So this is a molality to molarity conversion. Okay, so I have 0.796 moles of acetic acid per 1 kilogram of water. I need to go from moles per kilogram to moles of acetic acid over the liters of acetic acid solution. Okay, so I already have the moles. I have 0.796 moles. That's already 0.796 moles of acetic acid. I just need to get the liters of the total solution. The solution is water plus acetic acid. If I can get the amount of acetic acid and the total grams of water, I can use the density and convert it to milliliters and then to liters. So let's go ahead and convert the 0.796 moles of acetic acid to grams. I know that in 1 mole of acetic acid, I have 60.05 grams, according to the periodic table. So that ends up being 47.80 grams of acetic acid. To get the total mass of the solution, I have 1,000 grams, which is 1 kilogram, plus 47.80 grams of acetic acid. That will equal 1,047.80 grams of acetic acid. I can convert those grams to milliliters by using the density that's given. So if I multiply, if I use this and divide by the density, which is 1.004 grams of acetic acid per 1 mil, and then convert the mils to liters, the liters of acetic acid solution I get is 1.044 liters. So I have my liters, I have my moles. I just need to take 0.796 moles divided by 1.044 liters. And so the molarity of my acetic acid solution is 0.762 molar.